Okay, so today we're talking about the half angle and double angle formulas and the reduction formulas. And today you really want to have your formula sheet with you while you're doing these problems so that you can learn where these formulas are on the formula sheet, and that way it'll be much easier for you to use them. So here on the formula sheet, on the first page, here are the double angle formulas here. And then it starts the half angle formulas, and you can see the plus or minus there. And then on the top of the second page, we continue with the half angle formulas. So these are the formulas that you're going to need to know for for this section. All right, so the first problem says sine of x is equal to 3/4. And so that means that my opposite is 3. And be careful here, this is not a 3, 4, 5 triangle. My hypotenuse is 4. And it says that it's in the first quadrant. And so this would be 3, this would be 4, and then 4 squared is equal to 3 squared plus b squared. So 16 is equal to 9 plus b, so 7 equals b, so this would be the square root of 7. All right, so now they want you to find the sine of 2x, the cosine of 2x, and the tangent of 2x. So first of all, the sine of 2x. So I just look on my formula, and the double angle formulas are here. So the sine of 2x only has one possibility. It's 2 sine of 2 theta is 2 sine theta cosine theta. So this is going to be 2 sine x cosine x. And here's x. And so it would be 2 times the sine of x, opposite over hypotenuse, times the cosine of x, which is adjacent over hypotenuse. And then the 2 and the 4 will cancel to give me a 2 here. And so I get 3 square root of 7 over 8. And so that's the first one. Part B, cosine of 2x. Now here we have 3 formulas that we can use. Right? We can either use cosine squared of theta minus sine squared of theta. We can use 2 cosine squared of theta minus 1, or we can use 1 minus 2 sine squared of theta. So here I'm going to just go ahead, since I already have the sine and it doesn't involve any square root, so I'm going to just use 1 minus 2 sine squared of theta. So this would be 1 minus 2 times 3/4 squared. And so that would be 1 minus 2 times 9/16, which I cancel those, and I get 1 minus 9/8, and so this would be, making my denominators the same, 8/8 minus 9/8 would give me negative 1/8. Okay, now I should get the same thing no matter what, which of the formulas that I use, because here I would get, if instead I said I'll just do one more just to show you that you get the same answer. If I say 2 cosine squared of theta minus 1, that would be 2 times, and the cosine of theta is the square root of 7/4 squared minus 1 will be 2 times, and the square root of 7 squared is just 7/16 minus 1, and this would give me 8 if I cancel the 2 and the 16. So I get 7/8 minus 1, which would be 8/8. I'll multiply numerator and denominator by 8. So 7/8 minus 8/8 again gives me negative 1/8. So you can see you're going to get the same answer no matter which formula you use here. All right. And then part C says the tangent of 2 theta. And so the tangent of 2 theta, again looking on your formula sheet, 2 tangent theta over 1 minus tangent squared of theta. And so this would be equal to, the tangent of theta would be opposite over adjacent. So that would be 3 over the square root of 7 divided by 1 minus 3 over the square root of 7 squared. So this would give me, this is 2 over 1, so 6 over the square root of 7 in the numerator. And then in the denominator, I'll have 1 minus, and 3 squared is 9, and the square root of 7 squared is 7. So this would be multiply numerator and denominator by 7, and I get 6 over the square root of 7 divided by 7 minus 9 over 7. And so that gives me 6 over the square root of 7 divided by negative 2/7. And then I'm going to change flip. So keep the numerator, change the division to multiplication, and then flip the denominator. And then notice here that the 6 and the 2 will cancel to give me 3. And the square root of 7 and the 7 will cancel to give me square root of 7. And then I still have this negative here. So my final answer will be negative 3 square root of 7. And that would be my tangent. So that's problem number 1. So now problem number 2 says, cosine squared of 34 degrees minus sine squared of 34 degrees is equal to cosine of A degrees. And then they said, what is A? So what I'm going to do here, I'm going to look on my formula sheet. And this one's on the second page. Oh, I'm sorry, that's not. It's on the first page. It says cosine squared of theta minus sine squared of theta is equal to 2 cosine of 2 theta. So here, notice theta is 34 degrees, and so 2 theta would be equal to 2 times 34 degrees. And so A is where the 2 theta goes. Do you see that? So cosine squared of theta minus sine squared of theta is equal to cosine of 2 theta. Right? So I would say that this is 68 degrees. So A would be equal to 68. And they already have the degrees written for you, so you just have to put 68 in the box. All right, and then that was part A. And then part B says cosine squared of 4x minus sine squared of 4x is equal to the cosine of b. And so again, using the same formula, this is the double angle formula for cosine. It would be that theta is equal to 4x, and so b is 2 theta, and so that would be 2 times 4x would be 8x. So b here is equal to 8x. Right? Problem number 3 says cosine of 6x and then all squared. And then it has equals box plus box times the cosine of, in parentheses, box x. So we have to fill in these 3 numbers. All right? So on this one, what we're going to look at is we're going to look at, again, one of my double angle formulas for cosine. And notice here, if I take this formula, this has cosine squared of theta in it. And it just has numbers other than that, and then I have the cosine of 2 theta. So this is the formula that I'm going to use, but I'm going to solve it for the cosine squared of theta. So I have cosine of 2 theta is equal to 2 cosine squared of theta minus 1. So I'm going to add 1 to both sides. And then I'm going to divide both sides by 2. Now if I rearrange this, I get cosine squared of theta, and then this would be 1/2 plus 1/2 cosine of 2 theta. So that tells me that in this little box, I get the 1/2. So I switched it around, and then I divided the 2 into both pieces. So this is going to be 1/2 in this box. This is going to be 1/2 in this box. Now, again, we have to say, well, what's usually here is theta. So in this case, theta is 6x. And so what do I want in here? I want 2 theta. So this little box is going to be 2 theta. So 2 times 6x would be 12x. Now be careful, don't write the x because the x is already there. So it's just going to be 12. Okay? So that is problem number 3. Problem number 4 says the cosecant of x is equal to 4, and it's between 90 degrees and 180 degrees. So in other words, it's in the second quadrant. Now what this really tells me is that the sine of x is equal to 1/4, because this is the reciprocal of the sine. So if this is 4/1, then the sine of x would be 1/4. And I know you can do it the other way, but it's just as easy to do it that way. All right, so I'm going to draw my triangle in the second quadrant, and this is going to be theta. Now, when we're working with these half angle formulas, well, let's finish up this triangle. So this would be the opposite, would be 1, and the hypotenuse would be 4. And so again, 1 squared plus b squared is equal to 4 squared. So 1 plus b squared is equal to 16. So b squared is equal to 15. So this would be the square root of 15. All right? Now, let's recall that when you're doing the half angle formulas, if theta is in either the first quadrant or if theta, the second quadrant or the first quadrant, when I take half of these angles, remember this is 180 and this is 90. So if I take half of 90, theta over 2 would be less than 45. And if I take half of 180, I get 90. So when theta is in either Q2 or Q1, then your half angle, so if theta is between 0 and 180, then I know that theta over 2 will be between 0 and 90. So the first and second quadrant, when you take the half angle, come into quadrant 1. All right? Now, if I'm between 180 and 360, so if I'm in quadrant 3, or if I'm in quadrant 4, when I take half of 180, I get 90. So 180 divided by 2 gives me 90. And 360 divided by 2 gives me 180. So that means my answer is going to be, so theta over 2 is going to be between 90 and 180. So it's going to be in the second quadrant. So the third and fourth quadrant, when you take the half angle, comes into the second quadrant, and the first and second quadrant go into the first quadrant. So that's important to know. So here I'm in the second quadrant, so theta over 2 is going to be in quadrant 1. So in other words, everything is going to be positive, all right? All right, so when I do my half angle formulas, because they want me to find the sine of x over 2 is part A. So looking at my formula for the sine of x over 2, and this again is on the bottom of the first page, it's plus or minus the square root of 1 minus cosine of, in this case, x over 2, all right? So looking at, this is my x, and so this would be my x over 2. So again, the x is going to be in the first, x over 2 is going to be in the first quadrant. So when I have to choose between plus or minus, in this case, it's always going to be plus. So it'll be the positive of 1 minus the cosine of theta is going to be adjacent over hypotenuse. So that would be square root of 15 over 4 divided by 2. Now, you can simplify that if you want to, or you can just write it like that in your answer thing, and it will take it just like that. So you don't really need to simplify it at all. Now, if you do simplify it, and again, I would recommend that you just leave it like this, but I'm going to show you how to do it. So this is over 1, and then times 4. And so this would be, because I want my denominators to be the same, so I'd have 4 minus the square root of 15 all over 4 divided by 2 over 1. And then I'm just going to keep change flip. So this would be 4 minus the square root of 15 over 4 times, and I flip the second one, So keep the numerator, change the division to multiplication, and flip the denominator. And so that would give me the square root of 4 minus the square root of 15 over 8. And that's how you simplify it. So the other ones will be very similar, and so I'm not going to simplify all of them. I just wanted to show you how to do the simplification. Now part B says, what is the cosine of x over 2? So looking at my formula for cosine, and it's on the second page of the formula sheet, and it's almost the same as the sine, except for instead of having a minus here, it has a plus here. So this is going to be, and again, I have to choose between plus or minus. So again, since I know that I'm going into the first quadrant, I know it's going to be plus. So this will be the positive, and you don't have to write the positive, of course, 1 plus the square root of 15/4 over 2. And again, the cosine of theta is square root of 15 over 4. All right? And then part C says, what is the tangent of x over 2? And so the tangent of x over 2, and I can use any of these that I want. So it doesn't matter which ones you use. And if you do the decimal approximation, it's hard to simplify them all to the same thing. But if you use a decimal approximation, you'll see that they're all the same. So I'm just going to go ahead and use this one. And again, it's plus or minus. And so I'll take the plus and the square root of 1 minus cosine of theta over 1 plus cosine of theta. And it would be plus or minus, but in this case I'm going to take the plus, and it would be 1 minus square root of 15 over 4 divided by 1 plus the square root of 15 over 4. And of course you could simplify that if you wanted to, but again, you can just type it in just like that. So there you have the half angle formula, problem number 4. Okay. Problem number 5 says 1 minus the cosine of 2b over the sine of 2b is equal to the tangent of b over 1. And they want you to prove this identity. So what I'm going to do is I'm going to plug in the double angle formula for cosine of 2b and the double angle formula for the sine of 2b. Now, it may take you a couple of times to figure out which formula to use, because remember, for the cosine of 2b, you have 3 different formulas to choose from. You can either choose from this one, or this one. But I do know that the sine of 2b has to be 2 sine b cosine b. So on this one, what we're going to do is the one that you should choose is